Beautiful. We are recording now. All right. So yes, I forgot about the recording this time. So let's try to do the question C. In maybe we can get it. All right. So the difference between the scores is 1. So we want the red dice minus the blue dice to be 1, or blue minus 1 to be 1. Both work. So for example, I can say 1 on the red and 2 on the blue, right? That possibility here, this little dot, if I subtract 2 minus 1, if I do that operation, 2 minus 1, the result will be 1, right? What else can I do about 2 and 1 now? Okay, that
6 minus
subtraction is going
5.
to give me 1. Which one, another one? Which another one?
6 minus 5.
Beautiful. So this one over here. Uh-huh. Anyone else? We have a lot. We have a lot.
5 minus 4. 4
5
minus
minus
3.
4. 4 minus 3. Uh-huh. 3 minus 2.
Yes.
All right. But also 4 minus 3. Huh?
And 5 minus 4.
Did you see? All right. I want to see something here. Because sometimes the book doesn't count that as possibilities. No, they are counting them. Beautiful. They are counting them. Excellent. Here. So for 1, I can say 2 minus 1, or guess the seed, right? That is it, yes. For 2, I can say 2 minus 1 or 3 minus 2. Huh? 4 minus 3 or 5 minus 4. 5 minus 4 or 6 minus 4. You see? Those would be the possibilities right there. If I do any of these, the difference will be 1. So our probability will be over 36, because we have 36 possibilities. And how many are our success? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the success will be 10. Probability 10 over 36. That's simple. That's simple. That's simple. All right, let's do another one. The score on the red dice is less than the score on the blue dice. Ooh, this one is going to take longer. Wait. This one is going to take longer. All right, we know it's going to be over 36. We know that one. We know, because there are 36 possibilities, right? And we are looking for the score on the red dice, these ones, to be lower, less than the score on the blue dice. So I
Two
can
and
say
one.
yes.
2 and 1.
What?
2 and 1.
Beautiful.
Blue
Yes.
2 and
Two,
1.
almost 1 and 2. Remember, this is a Cartesian plane, so we read it as x1, x first, and y first. So you may be talking about this one, 1 and
Yes.
2, because remember, we want the red dice, the one down, to be lower than the blue one, huh? 2, 1, this one over here, that doesn't work, right? Because the red dice will be bigger. So we cannot use that one. Can we use this one? Can we use 1, 1?
No,
No, right? Why no, Gabby?
because they're the same number. Like
Mm-hmm.
not less.
Beautiful. They are the same number, not less than, right? So we cannot use one. We cannot use that one. But we can use these, and these. All of these numbers are lower than 1. So we can use those. Same with these, right? Same with these. Can you guys notice the pattern? For 4, we can use these two. Only 5 and 6 are bigger than 4. Like these. And in the column of 6, we cannot use any number. So we have these as the possibilities. All we have to do is just count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 over 36. Huh? All right, guys, this is how how to do and how to read a sample space diagram. Now, we can jump into these exercises to make these things a little bit easier for us. Make things a little bit easier. All right. Let's see if I have enough time to do that. 9:15. Yes, I have 15 more minutes. But I have to explain three diagrams first. Ooh, let's do three diagrams first. Now, guys, if you ask me now, teacher, are a lot of questions in the examination? How many of the questions in the examinations are gonna be related to sample space diagrams? If you ask me that, I would say not that many. All right, not that many. The IB is gonna ask you about these sample space diagrams, but just maybe just one question. About these, the Venn diagrams, a lot more questions. But about these, where is it? The three diagrams. These. This is where the real questions are gonna come. All right? These is where the real questions are gonna come from. All right? So please pay as much attention as you can, guys. All right, here it comes. What is a tree diagram? Something like this. A diagram that you make with the possibilities as a tree, right? So for example, let's take a look at this example over here. This example is done already, so it is a lot easier to explain. We are going to roll two dice. The dice are fair, meaning that they have the same possibilities, right? Getting a 1 is the same possibility as getting a 2. The same possibility as getting a 3, as getting a 4, a 5, and a 6, right? The die is a fair dice. We're gonna throw one red and one blue. Now, how did you create this Venn diagram? Let's look at the questions. Now, we want a double 6, right? We want a double 6 for the first one. For the first question, we want a double 6 to be rolled. What is the probability of that? We can find this probability with a sample space diagram. We can. It is right here. Right? It is right here. We can see this probability. This is the option. This little dot in here. 1 over 36. From there, we can see that. But can we do it in a tree diagram? Yes. And the tree diagram could give us a lot more answers than that one. Here, for example, when we throw the red dice first, we have two options. Maybe we can have a 6, or maybe we can have not a 6. So what is the probability of getting a 6? Well, that one is easy. That one is 1 over 6, right? That probability is 1 over 6. So here, now you know what? Let me change into this configuration, into the board. Maybe I can show you how to do it better. Hey guys, all right. Maybe it's a lot easier for me to show you how to do this Venn diagram like this so that you can take it step by step, right? So remember the example. We're gonna throw two dice. One is red, the other one is blue, right? So we have the possibilities when throwing the red dice are 6 possibilities, to be honest, right? There are 6 possibilities. You can have a 1 and a 2 and a 3, 4, 5 and a 6. We could have all those possibilities. Those are
Profe,
possibilities that can be. Yes?
profe, hi. Lo que
Yes,
pasa es que Brian no tiene internet, entonces pues no se ha podido conectar bien a la clase. Entonces
Okay.
era para...
Okay, thank you. Fabian, appreciate it, brother. Thank you for letting me know.
Dale, profe.
All right. So again, in this diagram, we could have 6 possibilities, but since the question is what is the probability of getting a 6 and a 6, why don't we just focus our attention on that specific question? So we can have 2 options. We can have one option leading us to a 6 and one option leading us to a not a 6. Those are the 2 options we can have. Now, each of those options can have different probabilities. The probability of getting a 6 when you throw one dice It's absolutely simple. It's 1 over 6. We know that one. 1 over 6, right? There are 6 possibilities when throwing a dice, and one of those is the 6. So 1 over 6. There you go. But what is then the probability of getting not a 6? Something different than a 6. So getting a 1 or a 2 or a 3 or a 4 or a 5. 5 possibilities, right? So the probability here is 5 over 6. Things to notice about the tree diagram. Things to notice. Number 1, the little lines at the end of the lines are going to contain the possibility that we are studying. We are studying that we get a 6. And here we are studying that we get different than a 6, not a 6, right? Something else to notice. In the middle of the line, we are going to write down always. We are going to write down always the probability of this option, of this possibility. Here, this little number, which is in the middle of the line, represents the probability of this option. And that will continue happening for the entire diagram because we're going to expand this even further. All right. Something more to recognize. These two probabilities, if we add them, these two are always going to give us 1. 100%. Exact. 1. Always. If you add those two probabilities and the result is not 1, then you made a mistake somewhere and you need to fix it. All right. 1 over 6 plus 5 over 6 is 6 over 6, which is 1. In other words, these possibilities in the middle of the lines per sectors, we're going to see another sector in here in a minute, per sectors are always going to be the entire sample space, every single possibility. All right. Let me erase here. Like that. All right. And there we go. All right. Now, we have our red dice. We just throw 1 dice. Those are the options when we throw one dice. But the exercise said we wanted to throw 2 dice. So we need to expand this a little bit longer. We need to expand this. We're going to expand it into throwing the blue one. Blue. Right? And if we throw the blue one, this is the different sector for the different possibilities. Now, I could have, from here, I could have 2 possibilities. Wait. If I throw the second dice, I could have a 6 or maybe not a 6. That could happen, right? That could happen if I throw the second dice. Just what happened in the first one, right? Remember, in the middle of the lines, we are going to write down the possibilities of those options. So what is the possibility of getting a 6? 1 over 6. The possibility of not getting a 6? 5 over 6. Now, it might seem a little bit easier because all I did was repeat the same probabilities. Yes, and that is actually the strength of the tree diagram, that it is so easy that we cannot have it wrong. I mean, sometimes we could, but we just practice for those. All right. Same here. Maybe in the first dice, maybe we didn't get a 6, but we still are gonna throw the second one, right? So we have 2 options from here. We can have a 6 in the second dice, or maybe something different, not a 6. Maybe something different in the second dice. Again, the probabilities are going to be 1 over 6 and 5 over 6. Now that we have our Venn diagram, our tree diagram, we can answer all of the questions. We can answer a lot of questions. And look at this. The beauty of this diagram is that we can write intersections with this. Even though this is not a Venn diagram, we can find the probabilities of intersections in here. We can find the probabilities of, how do you call that? Man, I forgot the name. Con ah conditional probabilities. We can do conditional probabilities in here. This diagram is absolutely beautiful. Here is how. Let's go back to the questions. Oh, like this. Maybe a little bit bigger. Yes. All right. Let's take a look at the first question. I'm not going to show you the answers because I want to show you the processes myself. Let's take a look at the first question. So we want a double six to be rolled. How do you find the probability using our tree diagram? Here. We want double sixes. So the question is, which of these rows, because we have 4 rows in here. We have one row, a second row, third row, and fourth row. We have 4 rows at the end of our diagram, right? So which of those 4 rows is the one that we want to focus our attention? Well, we want double six, right? That is what we want. We want double six. So the only possibility is this one. This row in here. Because this one comes from getting a 6 and then getting a 6 again. Huh? Each of these rows represents possibilities. So for example, this one in here, this one. This would mean in the first dice, you get a 6, and in the second one, you don't get a 6. This is a possibility for 6-1 or 6-2, 6-3, 6-4, or 6-5. Okay? Same with this one. This row, for example, this one shows that in the first row, in the first die, I did not get a 6. This would be getting a 1 or 2 or whatever different than a 6. And then in the second one, you did get a 6. Huh? Yes?
And what happened with the probabilities?
Yes, we haven't get that far yet. Yes, we can find the probability at the end. Yes. But the idea here is to understand how to read the rows, right? The ways. Now that we have selected our way, our row, we can calculate the probability now. And the easiest way to calculate the probability is by multiplying these two. The probability in this row, let me do it with a different color. The probability in this row is 1/6 times 1/6, which is in this case 1/36. That's it. And it works for every single row. It works for every single row. So for example, let's say we want to calculate the probability of getting a 6 in the first dice and not getting a 6 on the second one. How do you do that? This is then 1/6 because of the first probability times 5/6 because of the second probability. This will be 5/36. Same with each and every one of these. This one will be 5/36 times 1/6, which is 5/36 as well. And at the end, this one, not 6 and not 6, will be 5/36 times 5/36. In other words, this is 25/36. 36, not 35, 36. There we go. No, this is 6. This is 6, and this is a 6, and this is a 6. There we go. 36. There we go. Calculating the probabilities with the tree diagram is absolutely easy. All you have to do is multiply the numbers on each of the rows. That's it. Quick things to know about this. Number 1, did you guys remember how I said that on every sector, the addition of the probabilities was 1? Look at that. 1/6 plus 5/6. That is 1. 1/6 plus 5/6. That is 1. But look at this. These probabilities at the end, if you add them, look at that. How much is that? This is 1/36. 5/36, 5/36, 25/36, the same denominator. So we're going to leave the denominator alone and add the numbers on top. Add the numerators. We have 1 plus 5 plus 5 plus 25. That is 36. So the addition of all the probabilities here is 36 over 36. 1. How beautiful is that? Every single sector gives us a complete probability. 1. How beautiful is that? Huh? Now, if you do this and the addition does not give you 1, then you have a mistake somewhere. This is one of the properties of the tree diagram. Extremely useful. We will see why in some examples in the future. All right. Let me erase these. All right, guys. Before we continue, let me ask a couple of questions. Are you following me with this? Are you understanding so far this diagram? Somebody please in the chat
Yes.
or open the mic. All right, thank you. Thank you, guys. Thank you, guys. Thank you. All right. So only a few of you answer, which means maybe the rest did understood but didn't want to answer. Look, if you're not understanding something, if you have questions about something, you can always ask me, right? I will stop and I will re-explain anything that you guys need, all right? I'm here for you guys. All right. Let's see, 6 more people. All right. You guys are saying yes. Beautiful, beautiful. Now, let's continue with our diagram. We can expand these. So the first answer is, of course, 1 over 36. That is going to be the first answer. Why? Because the question was finding the probability of getting 6 and 6. That is the double 6 of the question. The probability is 1 over 36. Let's see if we have more questions in the book. Here. Second one, B. Let's find the probability that we do not get 6s, meaning we don't get a 6 in the first one, and we also don't get a 6 in the second one. So what is the row that is going to give us not 6 and not 6? Right? So what is the probability that we do not get 6 and 6? I'm sorry, the probability that we do not get any 6. This one over here, 25 over 36. That is the probability. We are done. That is it. We are done. 25 over 36. Simple. We did not get a 6 on the first one, and we did not get a 6 on the second one. That is it. All right. C. Exactly 1 6 is rolled. Ooh, now the fun questions begin. Exactly 1 6 works. Again, just like the previous questions, we need to ask ourselves, which of these rows are going to give us exactly 1 dice? Can this row work? 6 and 6? Can it work or not? In the chat, please. No, right? It doesn't work, right? Because we are being asked to get just exactly 1 6. And this row is giving us 2 6s. So this one doesn't work. This one doesn't work. That row doesn't work. How about this one? Can this work? 6 and not 6. Can this row work for our question? In the chat, please. All right. Beautiful. By the way, Gally was the first person who said no at the beginning. And thank you to all the people who are saying yes right now. Yes, you guys are correct. That one works. This one works. So the probability of that one is 5 over 36. We did it already. Oh, but look at that. There is another option that works as well. We want exactly 1/6. So not getting a 6 in the first dice, but then getting a 6 on the second one, this row, this is a perfectly good possibility. We could have these. So what that means is that now we have two answers. What do we do here? Pretty simple. The solution is the addition of those probabilities. That's it. We have 5/36 plus 5/36. At the end, the answer of our question will be 10/36. 5/36 plus 5/36. 10/36. This will be the solution. The addition of all the possibilities that give us success. Now, I skipped this row here. I skipped it. Why? Because this one doesn't give us a 6. This one, not a 6 in the first one, not a 6 in the second one. And the question says exactly 1. So this one doesn't work. If it would have worked, because I don't know, maybe the question says allow this to happen, I don't know, then we just add this 25/36 as well. And that is it. That is how you find the probabilities. Absolutely simple. All right. Let's do the final question. At least 1/6. At least. Ooh, at least. Meaning we can have 1/6 or 2/6s because it is at least. Huh? Okay. What that means is that now this option in here, this possibility, this entire row can give us success. Because in here, because in here we have 6, 6, 2 6s. And the question says at least 1. Having 2 is a good option. So what is the probability at the end? Just add all the options then. We know that this one is a good possibility now, right? This one gives us success. So we add this to this to this. These 3 are the ones that give us at least 1/6. So what is the probability at the end? 11/36. Just like Cesar in the chat said. Beautiful, Cesar. Pretty good. All right, guys. This is how you use these 3 diagrams. Now, the more examples we do, the easier these exercises are going to be. But there is something important to know about this. Let's see if I find a question that I know is going to change your mind a little bit. Let's see. Maybe we do. Someone was saying something in the chat, maybe?
No, but I have a question.
Yes, sure. Tell me.
In the quizzes and the exams, the 3 diagram, they're only going to ask you about a specific number. Is that if they said, I don't know, 3 and 2 and 6, I don't know, is that, ¿puedo decirlo en español?
Okay, go ahead.
O sea, ahí solo te están preguntando por los 6, pero qué tal te pregunten de muchos más números, ahí ya no serviría el 3 diagram, ¿verdad?
Yes, it works. Why?
¿Sí? ¿Sería más grande?
Why? Yes, you can do, you can see it like that. 1, if you want to, you can do a 3 diagram with the 6 possibilities in the first dice. So 1, 2, 3, 4, 5, and 6. And then the second dice could have the 6 possibilities for each one of those 6. So 36 little lines at the end. That is a perfectly good 3 diagram. And you can do that. But that takes a lot of time, right? That takes a lot of time. So another possibility you can do is drawing a new diagram for the different number. So let's say maybe the diagram says now, maybe the question says, find the probability of getting a 7, a 3. Okay, then you draw a 3 diagram for the 3. And that's it, right?
Okay.
Okay, we have some questions in here. Let's see. Ooh. Place not in and put it back into the bag. No, I don't want this. No. This one is good. Number 3 is good. We can do that one in a second. Ah, no. Without replacements. These ones. Without replacement. But it looks like this. Yes, AP. These, it looks like these are for tomorrow. I wanted to show you these without replacement. Whew, that is going to change your mind a little bit. That is going to change your mind a little bit. All right. Let's try question number 3. Right? Let's try question number 3. Guys, from now on, it is 9:16, so it is your time to do exercises, all right? It is your time to do exercises. What I want you to do is go ahead and work on the exercises of 8N and 8O. That's it. Work on those 2 exercises, please. If you have questions of the 8M, you can also do those and ask me. The moment you get to some of these questions, you can always ask me. But please try to do number 3 as soon as possible. This one is pretty good. It's good because they are giving you the possibilities of some of the diagrams, of some of the options in the diagrams. And also because we have 2 conditional probabilities in here. Given that and given that. We have 2 conditional probabilities. So I'm going to teach you how to find conditional probabilities out of 2 diagram, out of a 3 diagram. But just when you get to do this one, all right? Get to do that one first. Please. I'm going to start the recording now.